Hey everyone. So in the previous video we ended our discussion by formally defining three terms: confidentiality, integrity and authenticity, which were the basis of information security. We also talked about a term called cryptography, which is a field in let's say computer science or mathematics that tries to solve these three problems using some kind of mathematical algorithms. So the focus of this video is going to be on the first aspect, which is confidentiality, and we will try to develop our own algorithm, our own kind of a mechanism, and try to analyze how secure it is when it comes to confidentiality. Right? Now, if you have not watched the first video, I would like you to go ahead and watch it first and then come back to this one so that you have a good flow, a good continuity in the concepts. So just to quickly define what confidentiality is, it is about the property that if two people are trying to communicate with each other, are sharing some sensitive information, some personal information, that information should not leak out to somebody who is not the intended listener, right? And in case it does leak out, then they should not be able to make any meaningful information out of it, right? So if I just break this definition down into two levels, I can call them as a physical level and another would be the logical level. So the physical level is something that prevents people physically from accessing the information, right? So it can be true for information as well as it can be true for some physical places as well. Examples could be locks or the lockers, where let's say if you have an important physical document, what you do is you keep that in the lockers, you keep that in the cupboards. If there are some sensitive places, sensitive areas, there are fences, there are security guards, and so on. In case of logical access, like logical restriction, we say that the physical access is actually already broken, that the person has already got hold of the information. Now the job is to not let them have any meaning coming out of it, right? So one example could be your code language. So as a kid, I'm guessing you might have had your own code language with one of your best friends, that if you're in a group of people and you want to talk something which should not be understood by anybody, you come up with your own kind of a code language. It could be some signs, some gestures, or maybe some words that the meaning is known only to the two of you. So the idea of confidentiality, like the idea of solving confidentiality using cryptographic algorithm, is very much similar to what we call or what we use as code languages. So we bring back the same concept of Alice and Bob, who are the friends and they are trying to talk with each other. Okay. So as I said, the message in itself is not hidden. It can be easily exposed of. In fact, anybody can read into the communication, right? So the problem is you should not send the message as it is, but you should first transform it, right? So I'm sure you would have come across some logical reasoning questions, like if you have a word something like cat and it translates to something like ECV in some code language, what would the word dog look like in the same code language? So what you do, you try to analyze, you try to go letter by letter and see if there is any pattern. So you can quickly understand in this example that the difference between C and E is of two letters, right? The same is the case with A and C, and same is the case with T and B as well. So you can use the same approach, the same formula for dog, and then you have the resultant encoded word. Now let's say we can use the same approach for Alice as well. So what Alice can do, let's imagine that she wants to transmit the same word, which is cat. So what she does, she takes the word cat, she adds 2 to all these letters, and then she arrives at this particular code word, which is ECV. She transmits this ECV and Bob receives this ECV. Now what Bob has to do is, he has to first know that the number which was used by Alice is actually 2. So once he knows the number, he has to subtract this number from each of these letters and he gets back the original message, which was cat. Looks like a very simple approach, very easy to understand, very easy to like implement. So let's see if this is good enough for the actual practical implementations. So before going into analyzing this method, let me try to break this down into two very broad elements, something like procedure, and there is another element which I can call it as a secret or a secret number, right? So in this case, what was the procedure? In Alice's case, it was addition, and in Bob's case, it was subtraction. And the secret number that they were established, like they were using, was 2. So before going further, let me take this procedure and secret kind of the framework and use it to understand the physical log structure. So if you see, the physical logs are actually exactly identical to this particular framework of procedure and a secret. So how does it look like? So in case of logs, what you do, you either turn the key clockwise or anti-clockwise in order to open it. And what is the secret? The key, obviously. So if you look at this particular mechanism, so what we want to do is we just try to have an analogy between the logical algorithm that we are trying to develop versus what is there already in the physical world. So in this case, if you think about the security aspect of log, as in if you want to judge how secure a particular log is or the whole system is, all the burden actually lies on this particular key. Why so? Because this particular operation of actually turning it like clockwise or anti-clockwise is pretty standard for all the logs. This is for a good reason, right? That every log you have, you don't want to have a manual in your hand and then try to fiddle around with the log using the keys. So then let's assume for some time that in the case of our discussion of algorithm, of our own mechanism, we say that the procedure is kept standard, that always the one who is going to send is going to add and the one who is going to receive or the one who is going to decode is going to subtract. Okay. Now the question is, if this is standard, in this case this was standard, so all the burden was on the key. And we know this for a fact that actually every single key is unique, because there is a lot of variations that you can make in the lengths, in the gaps between the teeth and so on. So the same case, let's see, can we do that? Can we implement in case of the secret number? So let's think about the same English language translation in this case. So what we did, we added a number, we subtracted a number. Okay. Now let's say to identify how difficult it is for somebody to break this kind of a logical log. Let's imagine that you are somebody who is trying to make some meaning out of this particular message. So you are Dave, you are a third party and you are not the actual intended receiver of this message. But as I said, this message can actually be seen by anybody. So if you want to make some meaning out of it, what Dave has to do, Dave has to try out different secret numbers so that he can actually arrive at the correct number, because he already knows that the procedure is established, as in the case of locks, that you already know that how the lock exactly opens. The same way you exactly know that ECV has come by addition of some number to the original message. So in order to break it, what Dave can do, he can start subtracting the number. Let's say ECV is the message that he receives. So what he can do, he can start subtracting 1 from each of the letters and he gets something like DBU. Now DBU does not make any sense to him, so he makes one more attempt. He subtracts one more time, 111, and he arrives at this message cat, which actually makes sense to him. So what he did actually, he actually tried just for 2 times and then he decoded that the secret number which was established between the two of them was actually 2. So the level of security which this particular mechanism provides is actually dependent on how many different possible secret numbers you can have, right? Because the same is true for keys also. So for our practical understanding, we imagine that the keys are actually infinite. So when we say each key is unique, we say that there are infinite number of keys, which means that there is no way you can unlock a lock by using some other key. Now the same has to be true, or let's say the same has to be implemented for this case as well. But now we are talking about English language where there are A to Z just 26 alphabets. So the problem here is that the secret number cannot go beyond 25, right? Why? Because let's say you think of number 26 and you add 26 to any of the letters, you actually arrive at the same letter back. So which means you just have 25 possible combinations, like 25 different secret numbers possible, or you can say you can have just 25 people. You can have just 25 people who can use this particular scheme that you have designed, which does not seem very good because you want this to have it to everybody. So then what is the problem? So what is the solution? That you have to somehow increase this number, but you are limited by the limited number of letters in the English language. You have only 26 letters. What do you do? So let's say, for the sake of this discussion, there is some magical way to increase this number from 25 to, let's say, 1 lakh, 1 billion, even 1 trillion. In fact, it is possible to make this number as long as you want it to be. So after having this assumption, does it mean that the procedure has no value? As in, it does not really matter how simple or how complex the procedure actually is. Okay, so I would like you to leave with this question. Think about it. If it makes sense, if it is reasonable to have some simple operations like just plus and minus, given that the key can be as long as you want it to be. Now how this magic happens is something that I can talk about separately in a separate video, but for the sake of this discussion you just have to assume that it is possible and then think about the procedure itself. Okay, so we will talk about this procedure problem and maybe also how this secret is generated in the following videos. Now if you like this effort, please consider subscribing to my channel and hit the like button. And the idea here is to make these concepts of cryptography or information security accessible to everyone who do not have any background on, let's say, engineering or mathematics, right? So thank you for watching and stay tuned for the upcoming videos.